And then he's going to introduce.
Hello, everyone again. This talk is about your BASIL, the functional safety spice is the name of this tool. The agenda is about quick overview of the tool for the one that see it for the first time, and then some list of updates and new features that has been developed in the last few weeks, and kind of let's say proposal to say create a standardization on about the traceability. So let's see quickly the updates, and then we'll focus on this topic. So BASIL is born, say, at Red Hat to support various functional safety certification. So the names comes from the BASIL that we target for virus, not about non-Italian pizza. And so we presented this the tool to an ELISA workshop like this in Berlin a few years ago. And then we say upstream at the tool as part of the ELISA GitHub, so it's publicly available on this website. And what is the goal of this tool is to establish traceability in your project and try to focus to put everything together. Most of the work needed in functional safety application in the same application. And let me just quickly share how this tool works. Essentially, you have a software component. For the one, you have to identify your reference document that can be, let's say, a software specification or source code, whatever document makes sense to you to develop the traceability on top of it. And once you have the reference document, you can split this document in snippets and create the traceability your work items on top of each snippet. So, and this is kind of let's say the relationship that you can establish on for the work item. If it's big enough, we can try to zoom a bit this one. So essentially, you can manage the software requirements nested in any way. You can specify test specification, test cases, justification, and any kind of documents or artifacts that can be, let's say, data used to train an AI model or whatever kind of artifacts that you want to map to your into your traceability. The tool itself comes also with a test infrastructure, so you will be able to run your test from within BASIL and trace your results in the application. So the idea is that you can have your web application in your company and share the tool for all your, say, associates or your employees, and then they will be able to interact with your devices, virtual machines, whatever you want to use, because the embedded test infrastructure is created on top of a Red Hat project that is named TMT. It's a Python module that abstract the test say execution in a way that you can run any kind of test suite written in any language against a different type of system under test. So that can be a virtual machine, a physical hardware, whatever you want. So with the same interface, you can run all the tests that you need in the same way. But it also support other kinds of test infrastructure. So like a GitLab, CI, like GitHub Action, GitLab. We also have a driver to interact with kernel CI, with testing farm, that is another Red Hat project for testing and other stuff. So a few key points about the tool. So essentially it's a web application that supports multi-user, and it provides, say, a web interface and an HTTP REST API. It supports, let's say, extended traceability because you can work on different work items. It also supports export to SPDX SBOM. It allows an admin to define and also user to define granular user permission. So you can say this user can read this one can write this, because there are projects where, for example, the same company, as per my experience, someone only can work on a project that you need to sign some NDA, or you can create an account for an assessor, for example, that can just visit and read your materials and navigate the instance. And then it provides in-app and email notification. As we said, its own test infrastructure. So the test infrastructure is this kind of list. The TMT is the default. Essentially, it just needs a YAML file to abstract the test that you want to run. And then from the tool itself, you can create your configuration file. Say, I want to run on this hardware using this SSH key, or run on a virtual machine running Fedora, or whatever operating system you need. And also we have now a driver to interact with Lava. That's another test infrastructure really common in open source, made by Linaro. That's available from one of the last version of BASIL. So, quick overview on what's new in the the work of the last few months, at least from last workshop. So, for some contribution, we now have standard, let's say, deployment workflow for Apache that was requested, but the default one is made based on Podman. So if you want to follow this, the default is using Podman pod, but it's also possible to deploy it via Apache. Now we had a problem with the export to SPDX, and that was implemented in one of the last releases in 1.6. And thanks to a new contribution that we had with Infomagos that have a talk just after this one, we understood that the exported file was not that good. So we had to refactor completely the feature, because the initial feature was based on, let's say, the official SPDX Python model that for some reason is not able to generate, at least from our experience, the let's say, the JSON that is, let's say, can be validated against the official schema. So we had a kind of a complete refactoring of the feature that is now also tested in CI using SPDX3 validates that under they will be using a Python model named the fiscal that will check the result against the original schema. So that should ensure us that any changes is not breaking the functionality anymore. So now we are also supporting the generation of a graph like this that you can use into the UI to just to double check that your traceability is as you expect. So to just have a quick understanding of how you organize your project. And we will see a quick demo later on. So we added a small functionality to be able to add some messages for users. So in case you have your shared application in the company, you need to inform people in case of downtime, or if you want to, let's say, change something in the infrastructure, you need to inform everyone in a single place. This functionality can be, let's say, organized from the admin setting configuration, that is a YAML file that is editable from the user interface. And we also added a check to inform people that are using the tool that a new release is available. So are minor changes, and we will see quickly those things on the live instance that we have for ELISA that has been updated with the last release. So the tool is publicly available, let's say an instance of the tool at this website. So you can register yourself and try to experiment with it. Let me open the instance, is this one. So you see, this is the URL, logged in with the admin user. So that's so let's see, we have a kind of a library that is collecting multiple software components, and want to open this one just to let you see how it is organized. On the left side, I have my specification that is the man page at the moment, and some let's say justification for sections that have no meaning with my project, and then I assigned to the synopsis the upstream version, let's say, code of the implementation of this function. You can see here you can see that the tool is automatically validating the snippet against the file that you targeted, saying this mapping is no longer valid because the code changed. So pay attention. And then there is a simple mapping to a piece of a specification of a single software requirement and a test case. So where you can make this, let's say, traceability really more complex, but just as a kind of example, where you can also navigate test results, see details of the logs and the artifacts. So you can also link bugs, bug fixes to each test result and whatever. So you can also specify a percentage of completion. So you can say, is enough this requirement to map this specification, and you can assign a percentage. It's an optional feature you can do or not. I mean, it's just to inform in a, let's say, an open community, to inform people that there is some gap that someone can also look at and try to fill, creating new tests or new requirements, new specification, or whatever. So let's see how we can create an SPDX SBOM. It's just a matter of pressing a button. That's the SPDX SBOM with all the information from the BASIL database, and so generate the traceability map in a view like that. And so you can understand, for example, how you organize your team. So using the same ID from the database. Actually, it's not, you cannot navigate the map, but let's see in the future. So, and so we saw the overview. So let's move to the other, the main topic that I want to share today. Sorry, there's another update is about the possibility now to integrate this tool with an external AI service. So essentially, you can have your let's say your AI provider URL and API key, and then from within the tool you will be able to interact with the AI with the custom prompt that will let's say will try to convert the output from the AI in a way that you can automatically populate the form that you need to create work items. So you will select a piece of the specification and you can ask AI, give me a suggestion to create software requirements. And the UI will be automatically populated with the result from the AI. Okay, so this is the feature. And it is working that way. So there is support in the backend API. So when the UI is checking if you have the configuration enabled, if it is enabled, it will add components to the UI to allow you to ask the AI about a suggestion. And the API, the backend API, it will interact via HTTP to the target OpenAI service, and will provide to you the response if it's possible to parse the response that is the prompt is forcing to, let's say, asking for a YAML file that is parsable, depending on the AI service that you are using. So if you're using, let's say, something on your machine, probably the result will not be that great. But so if you use, let's say, vendor tools, that will be really straightforward. So, and we also extended the possibility to hierarchical mapping the documents that was not possible before. And the main topic I want to talk about today is traceability as code. This is kind of a proposal that I came up with the last few weeks, trying to, let's say, standardize in some way the possibility to extract from external Git repository the data that we need to generate the traceability, because we work in open source, tests are in different repository, requirements in another repository. Developer like to have requirements in file, text file mostly. So there is this problem, no? And this is a proposal to solve it, and we can also, as a community of, let's say, tool maintainers, can also come up with a more complex idea of how we can create a standard. No, that's just an initial thing. So it's focusing on text files. Okay, so what can be the advantages of using this solution? So you can scan multiple external Git repository. You can have a configuration file that you can use in CI, or you can share with anyone in the world that can generate the same traceability just with this configuration file. And is not tied to a single work item format. So we can say extract data from the strict.doc format or from the aerospace format, or any kind of format also from the proposal that ELISA is doing for the Linux kernel. And but can be extended to all the formats. And let's say, as is written in Python, I mean, it's using a list of functions. It's easy to extend to custom rows if you need. So let's see how it works. So essentially, you define a list of software components and a repository to extract candidate files with some rules that can affect the file name, the path, the file content, or whatever. And then you will have to extract from that text file. You need to extract section if we are referring from the reference document or directly the work items data. So the extraction is made actually at each field level. So if you need to extract the title of our work items, you need to assign rules for the title. But if you need to extract the description as well, you need to do the same thing for the description. But it is based on a configuration file that is written in YAML, so you can use anchors to try to avoid code duplication and stuff like that. So we will see an example later. So after you extract the data, you can also filter over the extracted data for some criteria. There is also the possibility to have a relational search into the text. So you can say, find this text, and then starting from that point, look for the first iteration, for the first, say, occurrence of this other match that I need. And sorry, I have to update my operating system. And after you filter your data, you can also refactor the output, applying common rules like regular substitution, regular express substitution, replace, or I say just a simple uppercase, lowercase, or strip, the removing spaces or character from the string. And after you have your data, you can generate the traceability. The traceability in the tool is made reusing existing work items if they exist in the BASIL database, and if not, they will be created from scratch. So you have new work item in the database. Let's take an example. So this is an example snippet for configuring a repository. You need to find the URL, the branch, so you can also target commit, and file name pattern, a fold pattern, and you can also ask if the file need to contain some tag or not contain. Those are after the rules that are supported. So that is applied to each, let's say, configuration. So for each work item, you can say the requirements I want to look in this repository using those rules. For test cases, I need to look into this set of other repositories with other rules. No? And you can nest the way you nest the configuration, that way you will nest also the traceability. So you can have nested configuration like top level software requirements, and then you have low level requirements, test specification, test cases, whatever, also other artifacts, source code, whatever you want, and then you can configure those things and then call the CLI module extract the data. Let's take a look to a field configuration, an example. So to extract a piece of text from a text, you need to specify starting point and an end point. So this search can generate a list of things, of elements. It's not just a single match. And but you can also combine that with constants and say solution. In this example, for example, I'm looking for, this is related to the ELISA proposal. So in this example, we will look for the first implementation of this function in our file that we, let's say, identified in the repository configuration. And after that, we will look for the some expectation string that is the first event or occurrence of this text before the implementation, and we can add rules to say when this piece ended. And from that, we can generate a list of elements, splitting the list in some way. So this is kind of example. So and that will generate a list of requirements. So just that is generating many requirements. And as the file is changing in the kernel code, the new requirements will come up in the traceability. The same way, if a new test has been created in another test in another repository, it will come up in your traceability. Okay. So this is an example or more complete example of, say, configuration file. We can also use magic variables that are variables that start with a double underscore and with a double underscore, because during the elaboration, we create some information like we know the API we are working on, we know if it's the first requirement, we know many things, and then we can leverage those information to enrich the information on the work item that we are creating. So then we can filter the generated work items, because we can know in advance that there are things that we need to skip for some reason, like nodes or whatever text that have no effect for your traceability. So actually, this configuration file support those three simple rules. And then you can refactor the result using replace, reject substitution, uppercase, lowercase, and those things. So yeah, that's let's say just to say that we basically check if the work item already exists in the database. So this is a more complete example of the functionality. I want to show, let's say, a demo of it. This is the UI support. So let me open. So I mean, if you join the ELISA instance that we have, this feature is already there. So you can create an account and then you can play with it. So when you create an account in the ELISA instance, you are not immediately able to work in the application, because an administrator needs to provide you the rights. So it will promote your account from a guest to a user, because people are trying to, let's say, register with the fake email, so I don't trust them, so I don't promote their account to something, that can write things on that application. Okay, just because it's a public instance, it's the same in the company. So this is let's say my applications here. I have three libraries. Just an example. I have this feature here, traceability scanner. It's my local instance. So this is my configuration file. So I see I want to scan an API, fake API named the API1. That will be part of this library Munich workshop, and I will assign a version using a Git, the Git version, Git version. I want to extract data from this repository using those rules, and I will create essentially a single snippet from the start to the end of the document that I found. After that, I will start creating requirements on top of the set of snippets that has been identified here from the same repository. So I use the HTML anchors, because the repository defines an anchor here, so we can avoid say create the definition again. And after that, you can specify for each field, for example, BASIL for requirement support title and description, just that. So for title, for example, we will use an index and a constant value that will be propagated against the list of descriptions that has been extracted with a different rule. So we will identify the readmem definition, and then we will find, as I said before, this first occurrence of this string on the up direction, because there can be multiple API implemented in this file. And then we will end at this occurrence, and we will split everything to these. So after that, we will apply a transformation, so refactoring of the output. And so let's see what's happening. So what you need to do, just run a scan. It will create a log that you can open. It's ending for 47. On top, there is a list of scans. So I have 247. Yeah, 16. So this is the log. It will automatically update each 60 seconds, so you don't need to refresh it. So it will propose to you the same configuration that you use it because it's a single file. You can change it time. And then a kind of log of what is doing, extracting data, and a summary of what is creating. So it generated 6 software requirements. So let's see in the home page. So it will create a Munich workshop library and an API under the library with this version. And
Luigi, shop one in your like 4 to 5 more minutes.
I goes to
Good.
yeah, I want to keep some time for questions. Yeah. So this is the reference document that I use. I just asked for a single snippet, but I can, let's say, split it in a different way. And I created the requirements of capability. So this is just an example that have no sense if you have the same text split in a different way. But so just to propose, let's say, something to the audience. So, and this is a simple, flat requirement, let's say, mapping against a specification. So, and as we have time, just want to say a few things about the tool itself. So, from the tool itself, each work items have their own life cycle. So, you can have an approval life cycle where you can have someone that is approving it. You can see if you add it to the work item, you can change the status, and you will also see the changes that are made on the work item. So, I mean, anytime that someone changes something in the work item, you will see there are 2 information for the work item. One is about, let's see, one is about the work item itself, and the other one is about the mapping to the reference document, if is a first level mapping. No? And so any information that you change, you can see in this report. Also, you can also fork our work item. So if for some reason in a particular API you need to diverge, so you will keep the history that you generated it from another, and just will say fork to a new element that have a new ID. And then in the application itself, you can also manage comments, have a interaction with your colleagues inside the application. And each time something changes, you will be notified. Here, you will see a list of notifications, but you also receive email notification if you configure the tool with some email account. So, and actually, let's see. I think it's yeah, I reached the bottom of the agenda. So, I mean, if there is any questions or
Okay. How does this relate to the other traceability tools we have seen? So it seems to be very specific for the scenario and use case of testing and test execution, or something that,
let's say, is the testing is anyway something that we need to take care,
yeah.
So the idea is just to provide a single solution that allow people to use the same tool to do multiple stuff, the same place, collect artifacts in that place. So test execution can be also automated because the tool provides HTTP REST API. You can ask the tool to run the test, with the delays, or you can say run the test over the weekend, stuff like that. This is kind of a level of, but as I said, just to show something. The idea is to have a collaborative place where a group of people can work together on the same things, converging to a good solution with the evidence and everything that is needed to say provide also.
Hello, hello.
Because you have also an indication of what has been done and what is not yet done. So also supervisor or a group, say lead can have an idea, a clear idea on what is the status of, and it can also plan the work that needs to be done and understand the things. So I saw there is any question over the remote audience.
I was just dropping a message to Rina, but
Okay. So here is an example of me as a user can add the permission for a work item that for a component that I created. I can decide who can see that, who can read, who can write, who can edit. If I want to create a new one, and I can clone the same setting of configuration to a list of other software components. So there is this kind of operation that can take some time. So this is trying to simplify the things that can be done well in automation.
I see. You get the last question.
Oh, that's what like. Is this kind of a key piece for your continuous certification?
After that, there is a talk from Informagnos that they are creating a continuous certification framework that they will, let's say, have a talk. So let's say the tool is moving in that direction. So is essentially we are generating an SPDX SBOM with all the information from the specification to the test results. With
Okay.
So then I will stop the recording.